All right, we're going to start by finding the inverse of this function. So remember, to find the inverse, I'm going to change f of x to y, and then I'm going to exchange x and y. So I end up with y plus 3 cubed equals x. I want to solve for y, so I'm going to take the cube root of both sides. And then I need to subtract 3 from both sides. So I do not leave this as y equals. This is not y inverse equals. This is the function inverse of x equals the cube root of x minus 3. So this becomes cube root of x minus 3. Then I need to verify graphically that f of x and f inverse of x are inverse functions. I'm going to start by graphing the original. This is a cubic function. There are no stretches or compressions. There's just a translation to the left 3. So 3 of my anchor points are at 0, 0, 1, 1, and negative 1, negative 1. So that's 0, 0. I translate to the left 3. And then these two just follow since there's no stretches or compressions. The point that would have been at 2, 8 gets translated to the left 3. And so does the one that would be at negative 2, negative 8. So there are my 5 anchor points. 5 anchor points. And then I sketch in my graph. And it looks something like this, but better. Hopefully yours is better. And then I need to graph the inverse function. So the cube root function has the same first 3 anchor points here, these 3. And this just gets translated down 3. So this point here goes down 1, 2, 3. Well, and then these 2 points follow. Then this point that would be at 8, 2 gets translated down 3. And the one that would be at negative 8, negative 2 gets translated down 3. And then I sketch in my graph. It looks something like this. So then the other thing that I need to make sure that I draw in is the line y equals x. Oh, that is not it. Okay, back that up a little bit. Use a straight edge, and yours should be a lot more accurate than mine. Why do I keep hitting the wrong one? Oh, no, that's right. Maybe the first one was right, too. These lines look funky on the boards. There we go. And these 3 functions should all intersect at the same point. Notice that all 3 of these that I graphed have arrows on the end because they all continue to infinity or negative infinity. And you can see that this is my line of reflection. Then I need to verify algebraically. So in order to do that, I have to show that f inverse of x, okay, I have to find that first. So then this is going to be f of cube root of x minus 3. So I'm going to substitute that in, and I'm going to get cube root of x minus 3 plus 3 cubed. So that's really just the cube root of x cubed, which is x. So I have shown that the f of the f inverse of x equals x. So I have to now show that f inverse of f of x also equals x. So this would be f inverse of x plus 3 cubed. So when I substitute that in, I'm going to get the cube root of x plus 3 cubed minus 3. So that's going to give me x plus 3 minus 3, which equals x. Okay, so I have found the inverse, verified it graphically, verified it algebraically. All right, so next I'm given the f and g functions, and I want to find f of g of x and state its domain. And so I'm going to look at the domains of the original ones, because remember when you do this, it's the domain of G such that, it's the domain of G of X such that all those results live in the domain of F. So here, when I look at this function, this is a cubic function, so my domain is all real numbers. And this is a cube root function, so my domain is all real numbers, and that is fantastic news. That means in the end, my domain is all real numbers. So I want to find, it says f of g of x, which means that's f of the cube root of x minus 2. So that's going to be the cube root of x minus 2 cubed plus 4. So it's going to give me x minus 2 plus 4, which gives me x plus 2. That means that my answer then is that f of g of x equals x plus 2, and my domain is all real numbers. All right, so then we're given h of x. I'm going to find two functions, f and g, such that f of g of x equals h of x. All right, so remember we want to work from the inside out. I always think it's easier to find g of x first and then f of x. And there's multiple answers here that you could have. But if I just take this x plus 2 and I make that my g of x, then that would mean my f of x would have to be negative 4 over x plus 3. Okay? So this is one option. This would be like option number 1. Then I could have an option number 2 for f of x. Now, on a question like this, you do not have to give me more than one. I just want you to see that there's more than one. We're not even going to talk about all of them. I'll just give you another option here. So let's say instead of just saying that x plus 2 was g of x, what if I said that was 4 over x plus 2? If g of x is 4 over x plus 2, then f of x would have to be negative x plus 3. Or I could have made this negative, and that would have made this positive. Like there's some other options too, but those I think are the two, probably the most common ones that you would come up with. All right, so next part says graph each function. Hang on. Graph each function and identify its key characteristics. Okay, so this here is x to the 4th. So this is an even power function, so monomial, which means I know that the end behavior looks like this no matter what. And because it's a power function, then the function itself looks like a parabola. And it has a stretch of 2, vertical stretch of 2. So I know for that I'd be at 0, 0. And then if I substituted in a 1, right, 1 to the 4th is 1 times 2. Well, this would be a point here on my, an anchor point anyway, and it has a vertical stretch of 2. Looks like this. And then the next point would be way off my graph, so I don't need to have it. I just know that it gets pretty skinny pretty quickly. And I can sketch this in. And it looks something like that. Mine's a little lopsided there, but it's good enough. All right, so my domain is from negative infinity to infinity. My range goes from 0 to infinity, and I include the 0. Some of y'all were including infinities on things, and I don't know where in the heck you got that. All right, my x-intercept is at 0, 0. My y-intercept is at 0, 0. It's increasing from 0 to infinity. It's decreasing from negative infinity to 0. We have symmetry about the y-axis. Discontinuities, that would be none. Then as x approaches infinity, f of x approaches infinity. And as x approaches negative infinity, f of x approaches infinity. Okay, power functions should be fairly simple for you, hopefully. Alrighty, so now I want to find the zeros for the following two equations. So this is x to the fourth, and then this is x. That's actually a typo. That should be x squared right there. Okay, that should be x squared. So now I can just treat this like a quadratic, okay? And since this is x to the fourth and this is x squared. So if I multiply 36 times 1, I get 36. So this is positive, this is negative. So I need the two numbers to both be negative. They're going to have the same sign because this is positive. So basically they're going to have to add to give me 37. And so that would be -1 and -36. I don't even have to go through all of my factors there. So this is going to give me 36 x to the fourth minus x squared minus 36 x squared plus 1. All right, so then out of, I'm going to do my grouping here. So out of these two terms, I can factor out an x squared. That leaves me with 36x squared minus 1. Out of these two, I can factor out a -1, which leaves me with 36x squared minus 1. So that means I get 36x squared x squared minus 1. Then I can keep going, okay? So I need to completely factor this. This is a difference of two squares. So that would end up giving me 6x plus 1 times 6x minus 1. This is also a difference of two squares. So that would be x plus 1 times x minus 1. So that is completely factored, which even though it doesn't say that in instructions, that is what I expect to see. Then I need to actually find the zeros. Zeros means that it's in a set. Okay, so this is going to give me 1/6. That's going to give me a -1, so plus or minus 1/6, and then plus or minus 1. So those are the two parts to my answer. All right, so this next one, we need to factor this. So the first thing I can do is factor out an x. X squared minus 5x minus 14. I cannot lose this x. There were quite a few of you on the homework where these came up, that x just ended up disappearing like it wasn't even important. It is totally important. It is one of your zeros. You cannot lose it. You cannot forget about it. So he hangs out here, waits for us to finish the rest. A is 1, so that's fantastic. So I need two numbers that are going to multiply to give me 14. This is negative, so that means the signs are opposite. So they're going to have to subtract to give me a -5. So that would be a +2 and a -7. So that is completely factored. This is a cubic, and I have 1, 2, 3 factors. So I also am going to have 1, 2, 3 zeros. I have -2, 0, and 7. There's the other part to my answer. All right, so it says, given the graph of the polynomial function, determine whether A, the degree is even or odd, and B, the leading coefficient is positive or negative. And you can't just say odd and positive, or even and negative, or whatever. It is an even or odd degree and a positive or negative coefficient. Like, you need to be very specific and clear in what your answers are. So here, since it is up, up, okay, so if they are the same, that means it is an even degree. So A is even degree. And since it's up, up, that's going to give me a positive coefficient. All right, so these are opposite, which means that is an odd degree. And it is up, down, which means it is a negative coefficient. So next part says, give the zeros their multiplicities and describe the effect on the graph. The G has disappeared, but this says graph. All right, so here, this is already factored for me. That's nice. So I can figure out what my zeros are. I'm just going to go ahead and write them down so I don't mess anything up. My smallest one is going to be -4, then -5/2, then 1. All right, so this is -4, -5/2, and 1. So the multiplicity of the -4, right, -4 comes from there. The multiplicity is 2. The -5/2 comes from here. The multiplicity is 5. The 1 comes from here. The multiplicity is 1. Okay, so when it is even, that is like a balance, but that is not what we put here. I mean, that is what we're thinking. That's what I want you to see visually. But your real word that goes here is that it is tangent. It's tangent to the x-axis. Then when it's odd but greater than 1, then it is going to be a point of inflection. And honestly, I think I'm going to want y'all to write this out because I think a lot of you don't even know what the initials mean, because I've had some weird initials even. So point of inflection, write the words out. And then this has a multiplicity of 1, which means it just passes through. Okay, passes through the x-axis. All right, so this next one. On the quiz, there was some crazy weird stuff. Like, some of you just didn't even factor. You just used like the 3 and the 12. I don't even know what the heck happened. You totally made stuff up, but that's not how you find the zeros, so I don't know what the heck was going on. But you've got to factor this to find the zeros. So the first thing I can do is factor out the GCF. I can factor out an x cubed, but that's just a CF. That's not a GCF, because I can also factor out a 3. So 3x cubed, and then that leaves me with x squared plus 4x plus 4. And then this is a perfect square trinomial. So f of x is equal to 3x cubed times x plus 2 squared. Now, if you don't notice that it's a perfect square trinomial, not the end of the world if you first do 3x cubed times x plus 2 times x plus 2. However, you cannot leave it like this, or you're going to try and give me these separately and say they both have a multiplicity of 1, and that's wrong. You've got to combine it back and end up here. So if you don't recognize it as a perfect square trinomial, that's fine. I'm quite sure you can still factor it. Just know that you have to put those things together. And then this is my factored form, which means then that my zeros are going to be -2. And remember, this one is important. 0. It's also the easiest one, but we're making stuff up along the way. So I've got -2 and 0. My -2, the multiplicity is 2. The 0, the multiplicity is 3. So that makes this one here tangent, and this a point of inflection. Inflection. From a C in there. Inflection. All right, I'll write that. And then there isn't a third one. All right, so we're going to divide using long division or synthetic division. So there were some of you with given that choice on a question like this, you still did long division. I mean, hey, it's your prerogative, but I don't know why the heck you'd want to do that. It's definitely set equally for synthetic. So -5. And then I'm actually making this little box. I don't want to see random numbers all over your paper. This would be a 1, -17. Do not forget that you might have some placeholders you need to put in here, and if you're missing zeros in here, it's going to throw you off, and it makes a big difference. Look over your homework. Some of y'all got a lot of those wrong. Okay, so then bring down my 1, -5, -4, 20, 3, -15, and 0. Which means then this was x cubed, so this is x squared. So I end up with x squared minus 4x plus 3. So this next one, I don't have a choice. It's got to be long division because a is not 1 right here. So this is going to be 3x minus 2. Actually, I'm going to move over here a little bit. 3x minus 2. I'm going to divide that into 9x to the 4th plus 5. Oops, but it's not going to be 5x squared because this is x to the 4th, and then I need an x cubed term in there. So this is 0x cubed plus 5x squared plus 0x minus 12. Those placeholders, super important. Okay, so then I'm going to divide 3x into 9x to the 4th, which is going to give me 3x. This is 9x to the 4th minus 6x cubed. Go through there, change the signs. Those zero out, and I get 6x cubed. Bring this down. It's 5x squared. So 3x goes into 6x cubed. 2x squared times. So 2x squared times 3x is 6x cubed. Then this is going to give me negative 4x squared. Change the signs. Don't forget to change the signs. Watch your signs. That's what threw some of you off on some of these. So this is 9x squared. Bring this down, plus 0x. So 3x goes into 9x squared, positive 3x times. So that makes this 9x squared minus 6x. Change the signs. Those zero out. This gives me 6x minus 12 once I bring that down. So 3x goes into 6x, positive 2 times. This gives me 6x minus 4. Change my signs. That leaves me with a negative 8. Nothing else to bring down. That's my remainder. Therefore, my answer is 3x cubed plus 2x squared plus 3x plus 2 plus negative 8 over 3x minus 2. All right. Then I need to sketch this polynomial. In order to do that, I need to know a few things. So the first thing I need to know is where my x-intercepts are, where on the assignment that actually had stuff listed out that you had to put and ask for x-intercepts, and you had to put them as ordered pairs because it asked for x-intercepts. It doesn't really ask you here. You just have to know what they are so that you can graph them. So if you prefer to write them as zeros, it's fine because you're not asked something specific. I would suggest you write them out though so you don't mess anything up. So your smallest one looks like it would be 0, he's important, and then 2, and then 6. The other thing you're going to need is the y-intercept. Right, that is going to be an ordered pair. And since you have an x-intercept of 0, your y-intercept is also 0. However, let's talk about the y-intercept just a little bit, because what I noticed on the assignment was some of you were finding it and finding it correctly. And let's say it happened to be negative 12. Then you come over here, you need to make a little hash mark here, but you need to mark that that is negative 12. And some of you were doing that correctly, but then your graph wasn't actually going through that point. That's the whole reason of doing the point. So if I mark that negative 12 is right here, then it comes, and if it doesn't even hit it, that's a problem. Or if it's up here, that doesn't make any sense either. With your x-intercepts, if you're making hash marks, so let's see, 1, 2, 3, 4, 5, 6, 1, 2, 3. So if I'm making hash marks for the x-intercepts, the fact that I don't have numbers there is okay. But on the y-intercept, you need to actually mark what that number is and make sure you find it correctly. Okay, and then, let's see, this is 2, 3, this is a 4th degree polynomial, and this is a positive coefficient. So it's going to look like that for our end behavior. You also need to pay attention to these. This right here means that you're going to have, it's going to be tangent. So that's a bounce. What I also saw on the assignment was some of you were labeling that stuff correctly. You had bounce, you had point of inflection, but then when you went to graph it, you weren't actually graphing them. And so you said that there's tangent and that you have a bounce, but you didn't actually bounce anywhere. So make sure that you're paying attention. That's why you're writing this stuff down. That's why it has to, has to jive with your graph. All right, so let's make sure we have everything. Let's plot this stuff. So my zeros are at 0, 2, and 6. My y-intercept is at 0, 0, so it's already taken care of. I don't have to worry about marking it up here. And then my end behavior is important, and I have to bounce. And here's the other thing I saw, is that you correctly had it labeled. Some of you even put stars here, things like that, but then you bounced at 6, or you bounced at the wrong place. Make sure you're bouncing at the correct place. This right here is where it's going to be tangent to the axis. And you can only pass through the x-axis where you have these points. So if you were to start incorrectly, and so, let's see, I don't know, you came here, and then let's say you didn't bounce. So you came back up here, and then you came back down here, but you realized you had to end up, you don't get to come back up again because you're going to be crossing the x-axis again. Or I saw some people crossing it in here. I can't cross right there. The other thing is you have to be very careful because your shapes can be different. Yours may not look exactly like mine, but you have to be very careful not to go vertically either. If you're going vertical, you don't have a function anymore. So I know this is what my end behavior has to look like. My bounce is here. So I'm going to come down. I'm going to come back up like I'm going to come through this point, but it is tangent to the axis, comes down, and then back up like that. The other thing you have to make sure you're doing is everything is curvy, right? I don't know how far down it goes or how far up it goes or whatever, but it has to be curvy. No points, nothing is pointy anywhere. And that is the sketch of my graph.